Now that we have our part scanned and we have our mesh saved, we are going to bring the mesh inside Polyworks and create an inspection report. Right now we have our model brought in. It's a CAT part. We have the CATIA read in Polyworks, so we can import directly from CATIA V5 a CAT part. We created an inspection program to measure the pilot holes. You can see these are 128 pilot holes. We program that. We program the OML surface with a nice grid of 250,000 spacing to cover that OML contoured surface. And we also program the outside of the part profile. So basically the same thing that you would do on a CMM, we're doing this in Polyworks. In fact, Polyworks can even run a CMM. So same philosophy as you're currently doing on a CMM right now. The part is all programmed. So at this point, we're going to want to bring in the scan data. So we're going to import the scan data. There's the STL. We're going to import it, and it's not aligned yet. So the next point, we're going to do a rough alignment or a best fit alignment. So we're going to come in here and we're going to do a best fit alignment, and that's going to move the scan data on the CAD part. So now we got the scan data on the CAD part. Next, we're going to do a color map, and we're going to measure the profile of the whole part to the mesh. And it's looking beautiful. That's all in tolerance. And we'll check our tolerance. Our tolerance is set right now at plus or minus half a millimeter or 19 thousandths. Our tolerance needs to be set to the engineering drawing, which is plus or minus 15 thousandths profile. So we're going to fix that. We're still looking really good. Blue is if it's out of tolerance, plus, red is minus, and anything green is plus or minus 15 thousandths. We're very good there. Next, we're going to extract our hole information and our datum structure. So we're going to pull all that information from the scan data. And next, after that, we're going to extract our profile and contour points. So we're going to extract that. And then what we can do is we can turn on our holes, and you can see how really close they are in the best fit condition. But we want to have it in the datum rig. So we're going to run our datum alignment in Polyworks. We already have that all defined. So we're going to align it to the datums. The data is going to move slightly because now we're in a datum alignment instead of a best fit alignment. But you can see the data looks still very, very good. Everything I'm seeing is under 10 thousandths. So all these holes are within 28 thousandths true position. So at this point, if we wanted to make a report on the hole location, we could highlight what we have, and we could take a snapshot of that, and we could create a report. And our reports in Polyworks are 100% customized. We can write it to a PDF report or Excel report. We can write it to a custom AS9102 report. Very customized. You can do it exactly the way your customer wants to see it. So we will turn off the holes, and we're going to turn on the OML surface, and that's looking beautiful too. We're under, I don't even see, we got 1/5000, so everything looks like it's within plus or minus 5 there. We'll take a picture of that, and we're going to report that out. So you can see that our report is growing. Our report is growing. We got a picture of the holes up here. Now we have a picture of the profile, and we have data, and we're at plus or minus there. Now I see I made a mistake right here. I want to change that to 15 thousandths. Polyworks is very easy for that. So if I take that, I can come in here and I could change that to 15 and minus 0.15 and apply. And what that's going to do is going to automatically update the report. So you don't have to go back and do anything. It automatically updated the report, and you can see everything is passing. Okay? Very easy to create reports. So now what we're going to do is we're going to turn off the OML and we're going to turn on the profile. Let's make sure that that automatically followed the same profile, so that's really good. So we can come in here, we can spin this around. We can take several pictures if you want. You can spin it, you can take several pictures, and what we'll do is we'll take the profile and we're actually going to write that in a report. And now we're going to come in here and you can see we have different screen grabs of that, and then we have the report, and these are profile points, and we got to change that tolerance too. So we're going to come in here and we're going to pick our profile, we're going to turn that on, and we're going to change that to 15 thousandths also. And now that updated the report on that. So now that's plus or minus 15 on profile. So as you can see, creating an inspection report from scan data is very, very fast in Polyworks. Our data is all scanned within plus or minus 1 thousandths, well within any OEM aerospace requirements for measuring a part like this. We turned a process of maybe a half a day on a coordinate measure machine into something of probably 20 to 30 minutes in Polyworks. So this concludes the demonstration on 3D scanning and inspecting in Polyworks from 3D scan data. If you would like to have us come on site, look at your parts, bring out this HandyScan Black, spend the day measuring a few of your parts, creating some inspection programs, you can contact us at the link below this video. I think you'd be very impressed, and I think you'll see that a process like this that would take a half a day on a coordinate measure machine will be under 30 minutes with this HandyScan Black and Polyworks software.